children. In class 8th, you have learned about something about force. So, what you have learned in class 8th, how can you apply force? What a force can do. Next, what is force? Then, the two kinds of force with examples. What are the two kinds of force? What you have learned last year is contact forces and non-contact forces. Now we will see this at a glance. Now, what are the effects of force, or what a force can do? 1. Change the shape of an object. 2. Speed of a moving object. 3. Direction of moving object. 4. Speed and direction at a time, that is both. 5. It can bring a moving object to rest or an object at rest to move. Now, we will discuss about balanced and unbalanced forces. In balanced force, the applied force, let it be F1. The opposing or frictional force be F2. These two are equal and opposite. Then the resultant force will be 0. That is when F1 is equals to minus F2, since they are opposite in their direction, which is equals to 0, then it is balanced force. Now, coming to unbalanced force. When the applied force and frictional force are acting, then the resultant force is not equal to 0, then it is called as unbalanced force. That is, suppose F is resultant force, then F1 applied force, F2 frictional force, then F is equals to F1 minus F2 is not equal to 0, then it is unbalanced force. Till now, what we discussed: how can you apply force, what a force can do, what is force, the kinds of force, contact forces with examples and non-contact forces with examples, and a discussion on balanced and unbalanced forces. Now, this year, what we have to learn. So, what we are going to learn in class 9th, this is all an introduction class of class 8th, what you have learned, and with examples and so with small images and videos we have observed now. Now, what we are going to learn in this class? We are going to learn about the property of materials, that is inertia. How many kinds of inertia is there, with examples and day-to-day applications. Next, force and its laws of motion. When you are applying force, what happens to the moving bodies? This was given by Sir Isaac Newton, and we are going to learn about Newton's laws of motion. So, force and laws of motion and the property of materials we are going to learn in this class. In between, some new terminology definitions, how these laws of motions are arised, like what is meant by momentum and what is actually force. Till now, what is the force? We discussed the definition in some other way and how Newton has defined which law of Newton gives the definition of the force and what is meant by momentum and what is meant by impulse, what is conservation of momentum, and what are all the three laws of Newton and the derivations we are going to discuss in this chapter. Property of materials. What we are going to learn in this chapter is first property of materials, that is inertia. Three kinds of inertia. Second, Newton's laws of motion, that is force and laws of motion. Then related terms like momentum, impulse, recoil, conservation of momentum, and actual definition of force. Now, coming to the property of the materials or objects, that is inertia. What is the definition of inertia? Suppose if a body is at rest, it continues to be at rest. If a body is moving, it continues to be in motion only. For example, the planets are revolving and rotating about their axis and revolving around the sun. They continues to be in motion only. Whereas, if suppose some books are lying on the table, they will be lying the next day also, the other next day also, the third day also at the same place. This is called as inertia. That means the property of the objects which remain in a state of rest or in motion is known as inertia. Coming to the actual definition, if a body is in motion, it continues to be in motion, and if it is at rest, it continues to be in rest. That is, the state of rest or uniform motion of the objects will not be changed. This is called as inertia. Again, I am repeating the definition. The tendency of an object to oppose or resist any change in its state of rest or of uniform motion is called inertia of a body. We will see with some examples. So, that means if a body is at rest, it continues to be at rest only. And if it is in motion, it continues to be in motion. This property, the tendency of this body object to resist, either its state of rest or of uniform motion, is called as inertia of the body. Now, how many kinds of inertia are there? There are 3 kinds of inertia. Coming to the types of inertia. There are 3 types of inertia. 1. Inertia of rest, inertia of motion, inertia of direction. Coming to the examples, now in inertia of rest, when a body is at rest, suddenly when it moves, what will happen? Suppose, for example, if you hold a tree and shake the branches, the leaves will fall down. Same way, when a person is sitting in a bus which is at rest, suddenly when it starts, he will fall backward. Why? The reason is inertia of rest. What happens in this case? The analysis says that the legs which are in contact with the bus floor will automatically gains the velocity of the bus when it starts, but the upper body still it continues to be in the rest. This is the reason the passenger who is sitting in a bus when it is rest and suddenly starts falls backwards. Next, coming to the example of inertia of motion. The same example we can consider if a fast moving body or stopped or comes to rest. The passenger in a bus which is moving fast, suddenly when it comes to rest, he falls forward. The reason is the legs which are in contact with the floor of the bus comes immediately to rest position along with the bus, but the upper body still maintains the same velocity of the motion. When the bus is in motion, what velocity it is maintaining, the upper body continues to maintain the same velocity. That is the reason the person fall forward. This is the example of inertia of motion. Now coming to the example of inertia of direction. I think you have observed when you are moving in your car, suddenly it takes a curve, you will be falling in the opposite direction. This is due to inertia of direction. One more example, in the first chapter, in the circular motion, a boy is whirling the stone in a circle. Suddenly when the thread breaks or when he releases, it goes in the direction as the point in the straight direction, that is the point of direction at every point it changes. So it does not go in circle but it goes straight. This is called as inertia of direction. It is when a body is moving in a straight line, the body is still in the same direction. Suddenly when it takes a turn, it tries to move in that direction only. That is the reason they will fall in opposite direction when we are moving in a car or a bus. This is all the examples of inertia of rest, motion and direction. So many examples applications are there in day-to-day life. You please collect some more examples like this and you can present in your video presentation. Next, coming to what is Newton's first law of motion. Why we discussed inertia? Because Newton's first law of motion says about the force. Here, what is force we told already? Any physical quantity which changes the state of motion or rest or a moving body's speed and direction both at a time or shape, it is called as force. Physical quantity which tends to change the state of rest or motion of a body or speed and direction of a moving object or its shape is called as force. Now, what is the property we have studied till now? Inertia is the property of the materials. When you are applying some force, if it changes the property of inertia, then the body will be moving, changes its state of motion or rest. This is known as Newton's first law of motion or law of inertia. Now coming to the actual definition, when a body is continues to be in rest, it continues to be in rest only. When it is in uniform motion, it continues to be in uniform motion unless and until compelled by an external force. So, in simple words, change of the property of bodies, that is inertia, by applying force is called as law of inertia or Newton's first law of motion. Why Newton's first law of motion is this is the reason why Newton's first law of motion is also called as law of inertia. Why? Because it is changing the state, the property of inertia in the object is. What is inertia? The bodies are opposes or resist its state of motion or uniform motion or rest. This is actual property of the bodies. If this state can be changed by applying external force, this is called as Newton's first law of motion. For this, the supportive experiments are given by Galileo. Now, first he gave the word, the principle of inertia was given by Aristotle. He is a great scientist. Aristotle, he told that the inertia of the properties can be changed by a pull or push. Then another physicist, that is Galileo Galilei, he has conducted an experiment and he gave the principle of inertia that the bodies cannot change by themselves the state of rest or motion. And how it will be? He has done an experiment that he has taken one inclined plane and he has thrown a ball, and the ball was moving from one to the other inclined plane at the same height it reached. Now he started to decrease the height of the inclined plane and finally he made it to coincide with the horizontal component of the earth, and he observed in the 3 experiments the movement of the ball, how much it has reached. When the inclination was completely made zero, then the body is moved farther far. This is called as principle of inertia, and this has given an idea to Newton to deduce the first law of motion or law of inertia. When you are throwing a ball or pushing a ball, or by applying you are dropping a ball on anywhere, these are all the application of forces. When you are doing, then you are changing the property of inertia of that ball from rest to motion. Now this idea was taken into consideration, and he defined the law of inertia. Now in the next class we will be seeing what is the relation between inertia and the mass of the bodies. Inertia is a property. It is not a physical quantity. Then how can you measure the inertia? You can measure the inertia by considering the mass of the objects. So inertia mass of any body is the measure of inertia. With this small demonstration, you can observe that when you are throwing a ball onto the cardboard pieces, all are fallen down. But when you are throwing a crumpled paper, they are like that only. There, what is the difference? The difference is only the mass of the ball and mass of the crumpled paper. So mass of the ball is greater and mass of the crumpled paper is less. So you can say that mass is the measure of inertia. When mass is more, then the inertia is directly proportional to the mass of the objects. Next class we will be seeing Newton's second law of motion, and so this is the definition you have given. How this definition came? What is the actual definition of, till now, what is mean by force? All the children will say a pull or push. This is misconception what the child is developing. What is actually force? This Newton's second law will be deriving what is force. The definition is given in the first law. How can you apply? How can you apply the force? What a force can do? Then what a force can do, when you are keeping all the words together, you will be getting some general definition. What is force? Now Newton's second law derives and gives the mathematical derivation for calculating the force.